Okay. So, what are we going to learn today? We'll talk about first what do we mean by periodic functions, and then hello Tanvi, welcome back brother. Tanvi, can you hear me okay?
Yes, sir.
Okay. Alright, so I was just saying welcome back. You made a complete world tour and you're back to your location. Okay. And Tanvi, if I may ask, you are in which time zone? You are in which time zone right now, Tanvi? Pacific, Central, Eastern, Mountain? Okay. Tanvi would answer that later. I think you are not going to hear me, but it's okay. I was just trying to figure out what is the time for you. So, what we wanted to do today was, we wanted to talk about periodic functions and then look at some of the basic properties of a periodic function. When you talk about periodic function, what does it mean? What are the different elements of a function that you call as periodic function? And then go back to the trigonometric functions, sine, cos and tan, and try plotting that and see if they are periodic by any means or not. Okay? Dave, Pranit, you can hear me, right?
Yes, sir.
Okay. So, yeah. Tanvi, can you hear me okay now? Sorry, Dhanushri. Yeah. Dhanushri, can you hear me okay?
Yes, sir.
Okay. All right. So let's get started. I will not repeat what we want to talk about, but still I have to say that because Dhanushri has just joined now. So we'll talk about periodic function, the basic properties of a periodic function, and then we'll look at trigonometric functions, try plotting them on a graph, and then see does it have any correlation with what is a periodic function. Now, when we talk about a periodic function, what does it mean? Tanvi, can you hear me okay now?
Yeah, sorry, my internet went off, but my time zone is PST.
PST? Okay. Yeah. Alright. So, let's talk about what is a periodic function first. If I say y is a function of x, 3x plus, which is equal to 3x plus 2 or 3x plus 7, whatever. It's a linear function, right? Because it plots a straight line for us. Yeah? If you talk about y equal to y as a function of x, which equals x squared plus 4x plus 9. It's a quadratic function, right? It plots a parabola for us. So we have seen a linear function and a quadratic function. What is a periodic function? Where does it fit in? Any idea? Yes, Dave. Exactly. Periodic function is a function that creates a shape over and over again, periodically. Okay? So, now let me not tell you guys anything about it, let me not give you any clue, but based on whatever definition Dave gave, let me just reuse that. So Dave is saying that you have a coordinate plane, and you have a better marker. So you have a coordinate plane with a better marker, and you have a function. Let's say y is a function of x. I'm not tell you what. Okay, let's say it's a function of x, and there's something after that. which plots something like a wave. Started, completed one cycle, again started, completed another cycle, starts, completed another cycle. This is a classic example of a periodic function. So let's try to visualize this quickly, and then we will. Let's say I am talking about a function which starts like this. Okay. A function, I have not disclosed what function it is, description, the elements, everything. I am just saying that there is a function y equal to a function of x, which is plotting it like this. If you look at this, there are three things that you would need to be aware of. And again, I am talking about symmetric shapes coming out of it. Okay. So you see that okay, starting from here, completed one cycle. Again starts, follows the same path, second cycle, third cycle. If you go backward, it continues. So there is something called midline. If you visualize this, you will find that this function or whatever graph is being plotted, it is symmetric against this middle line. This is called midline. And then you will see there is a uptick here, and there is a dip here. These two are the rays or fall of this graph against that midline, which is called together as an amplitude. This is called amplitude, and this is called midline. If you guys know any other name for this, let me know. Dave, am I saying it right so far? And you guys can correct me for the benefit of the group. If I am saying something which is not right, correct me.
So you're kind of good. You just commented.
Yeah, I did. No, I was saying that if you are looking at a periodic function like the way you described, periodic function is a function which helps you plot a graph on a coordinate plane where you will see the same shape getting repeated over and over again periodically. That's why it's called periodic function.
Yeah.
And then you will see that it starts from a point. If you just pick up a point randomly and let's say along the y-axis and see when there is a complete circle and comes back to that point, from here to the same starting point again, here to here it is called one cycle. Here to here is one complete cycle, and this distance from here to here along the x-axis is called a period. This is one period or one cycle. Okay? Yeah.
Does the x-axis always have to be the midline, or can it be like other?
It can be anywhere. Okay? So let's say, since I have not given you guys any legitimate function yet, so this point is valid, but I would be completely wrong if I say that my graph is always like this. I can have a periodic function like this also. And in that case, a line which kind of splits this into two equal parts or two mirror image of each other, that is called the midline. And the highest point and the lowest point in the graph, if you take the total distance between these two, this is called amplitude. Amplitude. Okay? Yeah.
So does that mean there can only be 0 or infinity roots?
I will come back to that question. Let me first mention this. This is midline. This is called amplitude. Yeah, sorry. One more
Does
time.
that mean there can only be 0 or infinity roots, like x intercepts?
From where that comes. We are not talking about roots yet.
You know, this parabola, it kind of looks like a parabola.
It's like infinite number of parabolas combined one after another.
Yeah.
It's not one parabola actually. Yeah?
Yeah.
Because this cyclic this periodic function has no starting ending point. It will go on till the size of your graph. Yes, Praneeth? I mean, board. Yes, Praneeth?
For the amplitude, is it from midline to the top or the entire thing?
Midline to the top and midline to the bottom, both together, that's called the amplitude. That gives, I'm sorry?
So both of those two combined is the amplitude?
Both of the two combined is called the amplitude. Yeah. And if I find whatever I said is wrong, I'll correct myself. But for now, this is what my understanding is. So, but before I move on, Dhanushri, Tanvi, and Dev, are you guys clear about whatever I have said so far? And you guys can happily say that, sir, you have not taught anything so far, and that is correct. I have not taught anything so far. I'm just giving you guys what do you mean by how do we visualize or relate to the basic concept of a periodic function. So this from the maximum point to the minimum point, this distance is called the amplitude. The line that, an invisible line that splits this graph into two equal parts or two mirror images of each other is called the midline. And then let's take a point here on the x-axis. If you look at this point here, for every increase of x, y is decreasing, right? Your slope is decreasing actually. Once it comes to this point, the minimum point, you will see that every increase of x, value of y is now increasing. So slope, here the slope is decreasing, then starts increasing. And again, it continues increasing this point and then again decreases to come back to the same starting point. From here to here, this is called one cycle of this wave or this periodic function, and the distance along the x-axis, this is called the period of the function. Yeah? So this is just the theory part. Okay? Now let's get into some interesting concepts and see where do we see these periodic functions. I have only given you guys some pictorial representation of it and given some basic background about it. But what kind of equation, what kind of function draws this? Let's look at it. Anybody have any clue before I start? What kind of equation plots a periodic function?
Since it has parabolas, does it have something to do with that?
Say that one more time.
Does it have something to do with the parabola equation?
Meaning quadratic equation, a quadratic function?
Yeah.
Yeah, Praneeth.
I think that's sine and cos functions.
Okay. Let's see what Tanvi says. Yes, Tanvi.
I'm going to say like trigonometric function.
Trigonometric functions. Trigonometric functions. So now when we talk about trigonometric functions, so Dev, is that your understanding as well?
Yes, sir.
Dhanushri, are you aware as well?
Yes.
Okay. So anyways, if everybody is aware, still I will make sure that I repeat it, because when we talk about periodic functions, we touch upon a couple of concepts. We touch upon the basic trigonometry understanding, we touch upon the unit circle theorem, we apply that, and then obviously basic geometry. So let's look at it. This is a combination of a couple of concepts. So now, if you guys remember, some time ago I had created a table of sine, cos and tan values for the most commonly used angles, or let me say 0. At 30 degree I will put that in radian, okay? Pi by 6 radian or 30 degree, whatever makes it easy. 45 degree or pi by 4 radian. 60 degree or pi by 3 radian. 90 degree or pi by 2 radian. Okay? And then Sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1, 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And sine by cos is 10, so this is 0 by 1 is 0, 1 by root 3, 1, root 3, infinity. Okay. Let me try making this table smaller. Okay. This table will probably bother you a little bit more, but this table will be our source of information for today's calculation. Okay. Let me make. Okay. I will take 0, 45, 90, and then 180, and then minus 45, minus 90, minus 180. Now you'll say I have filled the board completely. Where will I do anything else? Sine 0, 0, cos 0, 1, 10, 0. 1 by root 2, 1 by root 2, 1. 90, sine 90 is 1, cos 90 is 0, tan 90 is infinity. Now whatever you see here, okay, 180, 45, minus 45, minus 90, minus 180. These angles, how do we find it out? Do you guys know how do we get these values? Because if we get these values, then we can just put it on the graph paper. It will be very easy. Okay. So, come back to unit circle theorem. Okay. This is your x-axis, this is your y-axis, and you know that any and every point on this has, this is cos theta and sin theta. This is the angle with the party x-axis. Okay. If you guys remember, I think Tanvi was not in the class when we were talking about unit circle theorem. But for most of you, if you remember or recall whatever we talked about unit circle theorem helps us. If you are looking at a right angle triangle to find out the value of theta, you can only go up till 90. That's why I have filled the value till 90 only. But then, if you have to look at larger angles, this is where unit circle theorem comes into play. Okay? Visualize this as x and y coordinates. Am I going too fast without keeping you guys with me always? So far, everybody with me? Tanvi, Dhanushri, Dev, Praneet, everybody? And you don't have to say yes if everybody else is saying yes, okay? If I am just rushing through it, just please stop me, okay? I'm not teaching for myself, I'm teaching for you guys. Tanvi, are you with me, daughter? Yeah, okay. So this, when you talk about unit circle theorem, I might go back to the basics and might waste a lot of time for you guys, but bear with me. When you talk about unit circle theorem, it's nothing but a circle with radius as a unit, 1. And even if you have forgotten everything about it, unit circle theorem, only thing that you have to carry forward is any point on the circle, the x and y coordinate will be cos theta and sin theta. And if you still want to recall, maybe you can refer to the video of that class once. If not, come back to me. I will work on it. So here, any point on the perimeter of the circle will have x and y coordinates, cos theta and sin theta. Yeah. Now we are talking about sine 180 degree. Now look at this. X coordinate is cos theta, y coordinate is sin theta. Now when you are talking about 180 degree, meaning you are moving from here and coming all the way to here. when you make 180 degree, what is the y coordinate? What is the y coordinate? Literally 0, because it is falling on the x axis, right? So that will be 0. So when you are talking about sine 180 degree, you are simply talking about the y coordinate at that point, which is nothing but 0. See, without doing anything, you got it. Now, what will be the value of cos 180 degree? Look at this unit circle, 180 degree. When you come to this point, x coordinate is cos 180 degree. And what is the value of the x coordinate? This is 1, which is the radius of the unit circle, but in the negative direction. Is it making sense a bit to everybody? Dev, Dhanushri, Anvi, and trust me kids, I request you guys, okay, if there is anything that I am making it confusing for you guys, just think about yourself only, okay? We don't understand, we all don't understand everything the same way, so if I am making it complicated, just stop me, okay? I don't mind repeating it one more time. So now, we saw sine 180 degree and cos 180 degree just by visualizing this circle theorem. Yeah? Unit circle theorem. Now what will be the value of 180 degree? I don't care about all that. Sine by cos. 0 by minus 1. 0 by minus 1, 0 by minus 80, whatever it be. There is nothing called negative 0, right? So that's why I am just saying 0. So we got this value. Now let's look at sine minus 45 degree. So sine minus 45 degree will be, if I compare that or visualize that against the unit circle theorem or unit circle concepts, this when I am moving anti-clockwise, I am counting it positive. So when I am talking about minus 45 degree, I am talking about moving clockwise. So I would have probably made this angle of 45 degree and come to this point. Yeah. And so essentially my x coordinate value, the cos theta, will be positive. Okay. And will be same as whatever be the 45 degree in the positive direction. I mean for 45 degree. So it will be same as cos 45 degree. Wherein if you look at the y coordinate, since this is falling in the 4th coordinate, my y coordinate will be negative. So this absolute value is same as this one, but in the negative direction. It is same as minus of sine of 45 degree. Okay? Sine 45 is 1 by root 2. Sine minus 45 degree will be minus 1 by root 2. I am not doing a minus for this value here. I am looking at this to see what is my y coordinate value, which coordinate it is falling under, and then I am putting a negative to it. I am not saying sine 45 is 1 by root 2, so sine minus 45 is minus 1 by root 2. No, not that way. I am looking at that at the unit circle unit circle to find out the sign for that. Is that understandable, everybody? Yeah? Tanvi, I know you might be jet lagged, you just reached yesterday, but are you able to follow me better?
Yes, sir.
Okay. Dhanushri, Dev,
Yes, sir.
Sahib? Yeah. Okay. So, now, sine 45, see, sine 45 we got as minus 1 by 2. Cos 45, we are talking about this one. My x coordinate is always positive in this quadrant. Whatever is the value of cos 45, that will be the value of cos minus 45 also. No sign change. Yep. Then will be sine by cos, minus 1 by root 2 by 1 by root 2. 1 with a minus. Yep. Is everybody with me? Okay. Now, sine minus 90. Now it should be quick for us. When we say sine minus 90, I'm talking about a clockwise movement. So basically, I'm talking about this point. This is when I'm making 90 degree. That to minus. So this point, what is my x coordinate? X coordinate value is 0. What is my y coordinate value? Y coordinate is 1 because that is the radius of the circle, but with a minus. Yeah? So now sine 90 is my y coordinate. My sine minus 90 is minus 1. Cos 90 is 0. Yes, Tanvi.
I actually have a question about negative 45 degrees of the cos.
Uh-huh.
What's written on the whiteboard? I can see the whiteboard.
Okay, so cos, okay, first thing first is we have to visualize this against the unit circle theorem. Okay? So cos 45 and minus cos 45. What is the difference? When we say, not this, minus 45 degree. Okay? So when you visualize this against the unit circle theorem, okay? Unit circle. When you are talking about cos 45, you are talking about an anti-clockwise movement, meaning you are going 45 degrees to this place. When you talk about cos minus 45 degree, you measure minus or negative of the angle in the clockwise direction. So you move 45 degree but in the clockwise direction. So it's like this is 45 degree and this is minus 45 degree. It's an inverted right angle triangle. Same right angle triangle but with inverted this thing. Yeah? Now, so in this case, right, what is happening? Your x coordinate, if you visualize this against the coordinate plane now, your x value remains the same, be it positive, be it negative. Only your y value, in the first scenario when it is positive, y value is along the positive side of y axis, so it will be positive. In case of minus 45 degree, y will be along the negative side of the y axis. So it will be whatever is the absolute value, absolute length, you will put a minus to it. So that's why, what am I doing? My bad. So x coordinate which is my cos theta,
Yeah.
that will not change. Both will remain same. That's why if you see cos 45 and cos minus 45 are the same value. But my y coordinate value, which is nothing but sin theta. So sin 45 will be positive because it's along the positive side of y axis, and sin 45 will be negative, which is along the negative of y axis.
Yeah.
So that's why sin 45 is 1 by root 2, wherein sin minus 45 is minus 1 by root 2. Yes, Dave.
So that's
I would request you to be a little louder for me. I can barely hear you better.
I was saying like I thought for 45 degree thing was I thought it was root 2 over root 2, not 1.
Root 2 over
Root 2 for 45 degrees.
root 2 over root 2?
Yeah.
No, that will be 1. It is root 2 over 2. If
Yeah.
so that root 2 over 2 is nothing but 1 by root 2, right? So root 2 over 2, this you can put like this, right? Root 2 square. That will get you 2. So that's why it is 1 by root 2. Yeah?
Oh.
Okay. So again, trust me, this unit circle is something. I'll be honest with you guys. Okay, when I was studying in your grades, I never paid so much attention to this, okay? But when I was trying to teach you guys, that is when I realized the importance of this one. But okay, this one you can actually just visualize for any angle, and then you can use that to derive the value of different angles. So, Tanvi, did I make sense to you, beta?
Yes, sir.
Okay. Dhanushri, is that understandable so far?
Yes, sir.
Okay. Now, so we saw minus 45, minus 90 values. So tan of minus 90 will be sine by cos always. Minus 1 by 0. Minus 1 by 0. This is interesting. How much this will be?
Undefined.
Undefined, but what? A minus. If you are talking about infinity, lot of wealth. If you are talking about minus negative, minus infinity, you are talking about lot of debt. That's the difference. I was just saying, okay, it might be tempting to say, okay, undefined, but then undefined in which direction? That will come out handy for us. That's why I'm just stressing on that. So this becomes minus infinity. So we saw that tan of 90 is infinity, and tan of minus 90 is minus infinity. Okay. We'll come to this. Now I want you guys to use your visualization skills to find out the value of sine 180, sine minus 180. What am I talking about? First of all, what is minus 180? 180 will be this. Minus 180 will be in the clockwise direction. Again coming back to the same point. So I came to this point, and this point cos is this value, 1 unit, but in the negative direction. So x value is negative and y value is 0. So whatever represents the y value, which is apparently the sine of that, it will be same as for 180 and minus 180 both. So whatever was the values of sine 180, the y value, which is 0 here, and this is also coming to the same point, 0 here again, it will remain 0. Cos 180, cos 180, again same thing. Whatever was plus 180, same thing will be minus 180 also, because you are landing in the same place. So cos 180 will be same as cos minus 180. Same thing, 1 unit and the negative direction. So minus 1. Whether you relate with that or whether you just visualize it here, both are same. Yeah? Now what is the 10 of minus 180? Sine by cos, 0 by minus 1. This time no confusion, right? Only 0. I will not dare to say minus 0. Yeah? Now we have our table filled here. And that's it. Yeah, we have come to the end of the class. Is it? So, okay, that was a bad joke, dad joke, whatever you call it. But whatever we have done so far, is this clear to all of us? Tomorrow if somebody says, find out sine of 270 degree, it should not get you stressed out. If it does, that means I have not done my job right. Sine 270, always start from the basics. Make a unit circle. 270 when you are talking about 90, 180, 270. You come to this point. Sine of 270. At any point of the circle, unit circle has x coordinate as cos theta and y coordinate as sine theta. When you are talking about 270, you are talking about sine 270. Cos 270. Cos 270 is x coordinate, x value. When you are on this point, what is the value of x? Always a 0. Cos 270 is 0. What is the value of sine 270 here? The y coordinate, right? Y coordinate is how much? 1 in the negative direction. minus 1. Yeah? So, that's why the initial table that I am kind of almost forced you guys to remember, if you remember this table, 0, 30, 45, 60 and 90, all the values that we have derived, how it comes into play in the previous classes. But when you play with it couple of times, you'll end up memorizing it like the way I have memorized by now. So this table you will deal with enough till you are studying trigonometry, and then majority of the concepts around trigonometry, a majority of the value of the angles that you have to derive in sine, cos and tan form can be related to this one. Anything that comes in a very stupid shape, you have to find out 277. Then you have the calculator at your disposal. There is no teacher who can find this by any magic, because this is not falling in line with any of those commonly used angles. This is a very absolute value which you have to use calculator for. But otherwise, majority of the angles you should be able to use the composite rules as well as the basic values that we have derived. Is that okay, everybody? Okay. So now, with whatever we have done so far, let's look at how does it relate to the basic theory that we started with. Now let's try plotting sine curve. Okay. Let's try plotting sine function y equal to fx, which I had left as a mystery. Let me give it a name. Okay? And they must be laughing, being on mute, that this man took almost 45 minutes to come to this part. Now, this is theta. So this axis I will use as, since this is one of the input, I will use this as theta, my x-axis, and this y-axis I will use as y. Okay? Instead of x, I am using theta because I am using a sine function. Okay? This is the angle. Let's say this is 0, this is pi by 2, 90 degree, this is pi, 180 degree, this is 3 by 2 pi, and this is 2 pi. Let's go here, minus pi by 2, then pi, let's put pi by 4 also, just for the sake of minus pi by 4 also, because we have calculated that, right? So we'll use that, pi, 2 pi. Now, sine, we are going to look at this one. Sine 0 is 0. Okay, here. When theta is 0 degree, sine 0 is 0. Sine theta is 0 degree, y is equal to 0. Same point. When sine theta is 45 degree, so theta is 45 degree, sine 45 degree is nothing but 1 by root 2. Yeah? 1 by root 2 will be, it's like 1 by 4, 1 by 1.414 something, okay? Approximately. So it will be something like 0.7. Approximately, I am just rounding it. So when theta is pi by 4, let's say this is 1. Let's say this is 0.5 and this is 1. Okay? Are you guys with me so far? I'm just doing some mental math and then just trying to put it here, but I hope that I'm not complicating this for you guys. So this is my y-axis. I'm putting 0.5 and 1 because as you can see, right, everything is 0, 1, 0, 1. Only 10 is my outlier. We'll see what to do with that guy. Okay. So when theta is 0, we are trying to plot this one, okay? This sine function. When theta is 0, Sine 0 is 0. So this is my 1 point. When theta is 45 degree, this became 0.7. So maybe somewhere here. So when it's pi by 4, it's somewhere here maybe. Okay? When theta is 90 degree, it became y became 1. When theta is 180 degree, y became 0. When theta is 180 degree, meaning pi, and now you can see same thing. When theta is minus 45 degree, minus 1 by root 2. Minus 145 degree, minus 1 by root 2. Here and then here. Let's say this is 0.5 minus 1. Okay? And then when this is 180 degrees, again 0. So if you relate it, right, you will see this thing. Okay? And if we again use the same unit circle concept, you will see that the same graph keeps repeating for every pi. See, this is 1 pi, the other pi. So for one cycle of this whole wave, it took 2 pi. Here to here pi and here to here another pi. So this 2 pi became your period of this periodic function. So this, whatever mystery we started with, first mystery is solved. This is my sine, this is called sine curve or sine plotting of sine function. You would have heard about this term very often, say, okay, this is more like a sinusoidal curve. This sinusoidal curve is this. And this is this x-axis is your midline, right now. So, if you guys ask me, did we do anything magical? No. We just looked at the base value of sine, cos and tan. Then we use unit circle theorem to visually figure out how much the value will be for other angles. And then we have tried plotting the sine curve. Whatever value we have, we put theta along the x-axis and y along the y-axis. Because this was my curve that we were trying to plot. For 0 degree, this one, 45 degree, this one, 90 degree, this one. And when you plot it for this 2 pi range, I purposefully took 2 pi so that it gives me one complete cycle actually. So from any point, if you are starting from this point, from here to here is one cycle or one period. If you are picking up this point, so till you come to the same starting point, here to here is your one cycle or one period. So basically along the horizontal axis, once it comes back to the same starting point, that duration or that length is called the period. Okay? Is that making sense? Tanvi, are you with me, beta? Sahit, with me? Any doubt? Anybody? Dhanushri, Dev, Praneeth, Tanvi, anybody? No? Now the same thing you can do with cos value also. I'm not going to waste your time by doing it again in bits and pieces. But what I will tell you is, when you are starting from 0, what difference you will notice here in this case is, this. Here it starts from origin, it starts from 1. That's the only difference. See, sine is starting from 0, starting from 1. At 45 degrees, they are crossing each other. At 90 degrees, they are in the opposite place, like you see here. At 0, they're in the opposite place, 0 and 1, it flipped. 1 became 0, other one became 1. And the same thing repeats. So cos, plotting a cos function is also same as sine. Only thing is, sine is a starting point here from origin, cos is a starting point here. Because you know the sine 0 is 0 and cos 0 is 1. So that's the reason, that's the way you can visually relate and see the difference here. Is that okay so far? Did I make anybody sleep by any chance? No? How about you, Dev? Tanvi, Tanushri? I made you sleep, Dev? I was asking, the question was, did I make anybody sleep? Praneeth gave me a thumbs down. Dev gave me a thumbs up.
I was trying to.
Clear? Clear so far, right? Okay.
It's so glitchy.
I'm sorry, because?
The audio is like a little bit glitchy. So it's not right.
Right. No, that might be the case. Okay. But everybody is able to follow me so far, right? Dhanushri and Tanvi? I don't leave any child unless I hear a yes. That's a mandate. Okay. Alright. Can you hear me okay now, Dev? So sine and cos we saw, they are pretty much closely related. It's like a brother and sister. If this guy is a brother, this guy is a sister. This was starting from 0, starting from 1. And both follow the same pattern, just a little bit of shift. It's like you had a sine curve. Let's look at it this way. You had a sine curve started from here and followed this trajectory. When you're talking about cos, you imagine that this whole thing got shifted by 90 degrees. So instead of this peak being here, this peak is here. Okay? That's the only thing. So cos is a 90 degree shift from sine, or sine is a 90 degree shift from cos. That's how you can look at it. Yeah? Now the fun is with 10. Fun is actually with 10. Let's look at it. So this is my theta axis, this is my y axis, and we are trying to plot y equal to function of theta, not function of x, function of theta and tan theta. Tan theta. So let's say this is 0, pi by 4, pi by 2, 2 pi, and this is minus pi by 4. And again, when I say pi by 4, you guys can relate to that as 45 degree, pi by 6 is 60 degree, pi by 2 90 degree kind of thing, right? Radius to degree conversion, right? A radian to degree conversion. Okay? Pi by 2 pi. Okay? Now, when you see here, tan 0 is 0. Meaning when the angle is 0, y value is 0. 0, y value is 0. When angle is 45 degree, this one, let's say this is 0.5 and this is 1. When pi by 4, meaning 45 degree, it is 1. Oh, here. Now, when angle is 90 degree, here, let me do something little different here. I'll put a 1 here, 2 here. So when pi by 4, it is here. Pi by 4 is 1. Pi by 2, 90 infinity. When this is the case, I'm just putting a point here, okay? It's not infinity. It's closer to 90 degrees when this point is, okay? And we'll see what happens. And this, after this point, it just takes off. When you say tan theta is infinity, what you're talking about? when you say tan theta of any curve, you are essentially, what is tan theta? Tan theta is sin theta by cos theta. Yeah? If you compare that with the unit circle, sin theta, cos theta is this one, x-axis, and sin theta is nothing but y-axis. Tan theta is sin by cos, meaning y by x, right? Y is your sin theta, I mean y value, this one, and x value is sin theta, cos theta, meaning tan theta is y by x. Y by x, if you are looking at this as a line, what do you mean by y by x? How much y is changing for every change of x? That is nothing but the slope of the line. Yeah? So here, when you say tan theta is infinity, meaning y is changing much rapidly for every change of x. Meaning y literally took off without x changing. So that is what you will see here. 10, 180, okay, pi by 2 is 1, sorry, 10, pi by 2 is infinity here, pi by 4 negative is here, minus 1, and again same thing, minus negative is minus infinity. So if you look at this graph, you will see that this graph goes like this. When it approached pi by 2, it took off. Okay? Similarly, when it approached minus pi by 2, again took off. And again, after 90, you will see that this whole thing, again pi 180, 180 is here, pi by 4, pi by 2, and this is pi, not pi. And so you will see that. So you will see that 10 plots graph like this. For every between here to here. So basically for every 2 pi, it makes this curve and then shifts. If you plot it for 2 pi, 4 pi, 6 pi, you will see that this whole curve keeps on repeating actually. So the basic difference that we observe, but before I move on, did I make any sense to everybody or Ranit? Okay. Tanushree, okay? So okay. So from this one, what you see here is, even if you don't look at this 180 degree, okay? What you are seeing is, if you are trying to plot, this is pi by 4 and this is pi by 2, minus pi by 4 and minus pi by 2. What you are seeing is, this is what you are seeing. For 1 pi, meaning for every cycle of 180 degree, we plot this graph for us. So if you take if you go up to 2 pi, you will see that after every pi, this repeats, this whole thing repeats. Okay? You can use unit circle theorem to make your table bigger, go from 0 degree till let's say 6 pi on positive direction, 0 degree to minus 6 pi negative direction, and then try plotting it. You will see that for every pi, this cycle repeats. What we saw in terms of sine cos theta, for every 2 pi, this one cycle was completed. Okay? From here to here it was 2 pi. But in the case of 10, for every pi, it flips and becomes like a decoration that you see in marriages, in the pandals. Yeah. or Diwali or Christmas, right, where you see decoration, you have a wall and you will have those colorful lights falling on it. Your 10 is like this, a little more decorative than the regular Christmas lights. Yeah. And here, this is not this way, this goes, this takes off. At pi, when it comes to the bottom, pi by 2 minus or pi to pi by 2, it literally takes off, meaning your slope becomes infinity. Without x changing, y changes. These are called vertical asymptotes, which we will talk about later. We are not talking about it right now. Meaning the point where value of one parameter goes towards infinity, those are called asymptotes. Those are the turning point basically, right? So we just did a recap of the sine cos 10 value for up to 90 degree. Then we used that and our unit circle information or knowledge to visually find out the value for other angles, larger angles. Then we tried deriving the value for sine theta from 0 to 2 pi in the positive or negative direction. And then we tried just plotting that with theta being the horizontal axis and y being the vertical axis for sine, cos and tan. And we saw my sine starts from 0 and goes like this. My cos starts from here and goes like this. Similar to sine, starting point being different. And the amplitude that I was talking about, look at the amplitude of sine theta. It goes from 0 to 1 in one direction, minus 1 in another direction. What is the amplitude here? 2. 1 to minus 1. What is the period? 2 pi. It takes 2 pi to repeat the same cycle. What is the midline? Since we are talking about sine theta, midline is the x-axis here, or the theta axis. When we play with this equation a little bit more, then we'll see how the midline is changing. And then we saw tan theta, how does it behave? For every cycle of pi, you see this much decoration. Yep. And it literally takes off at pi by 2 in positive direction and minus pi by 2 in negative direction, because we see that tan theta, tan 90 degrees infinity, at tan minus 90 degrees minus infinity. That's why we see it taking off in both the direction at the beginning and end at those points, which we'll talk about later, but they are technically called vertical asymptotes in positive and negative direction. Any questions so far? Tiring, boring, frustrating? Something that we learned? Okay. Yep. So, the good thing is we have added one more thing to our vocabulary, right? We knew what is linear function, linear equation. We knew about quadratic functions or equations and what translates into when you look at a graph, right? Coordinate plane. Now we learned about periodic function where, some of you were already knowing it, but we kind of learned it together that when you talk about a periodic function, you're essentially talking about the trigonometric functions which help you draw something which is periodic in nature, and it's a predictable frequency or predictable pattern that gets derived out of it, and we saw sine, cos and tan being plotted. So I will not tell one more time what we learned. I hope whatever we learned, everybody is with me. Any questions before I assume anything? Tanvi, Dhanushri, Praneet, Dev. All clear? Okay. Then I will let you guys go, enjoy the rest of your evening. I know you guys are a little emotional right now. School is about to start in a couple of weeks, but that's part of life. See you guys on Saturday. Alright? Bye bye, take care. Bye bye, bye bye.